Okay, so I want us to revise the Form 2 paper, chemistry. So let me open. Okay, here it is. The paper is here. Let me zoom it so that we can see clearly. Okay, we have answered the first question, whereby we are supposed to distinguish atomic number and mass number. We have said atomic number is the number of protons in an atom, the number of protons in an atom of an element, while mass number is the number of protons and neutrons in an atom. That one we have answered. Number 2, state 3 subatomic particles in an atom. We have said we have protons, electrons, and neutrons. Now we are at number 3. So read number 2. Read number 2. Soma namba 2.
The elements sodium, lithium, and potassium form an important family of elements.
Yes.
Name the family in which these elements belong.
Yes. So we have sodium, lithium, and potassium. Which family do they belong? The 3 of them. These are what? They belong to which group? Okay, they belong to group 1. These are group 1 elements, and the name to group 1 elements is alkali metals. Alkali metals. Sawa sawa. Alkali metals. Sawa.
Yes.
Yes, I read B. If you have any question as we proceed, you can ask. Yes, so alkali metals is the name. Soma B.
State and explain the trends which with reference to the above family and properties down the group.
Yes, okay. So we start with atomic radius. So group
Radius.
1 elements, yeah, you can see, okay. The first one is lithium, followed by sodium, followed by potassium. So what will happen, or what is the trend as you trend of the atomic radius as you go down the group? Atomic radius, will it increase or decrease? That is the question.
Increases.
The atomic radius, it increases. Why?
Because it gains more energy levels.
Very good. Yes, there is increase in the number of energy levels as you go down the group. And the Collins, I've told you, you take some notes just for revision, right?
Yes.
Yes. So as you go down the group 1 element, you find that the atomic radius increases. This is due to the increase in the number of energy levels as you go down the group. Correct. Okay. Ionic radius. Increase or decrease down the group? Just make a try.
Radius also increases.
Also increases. Very correct. Explain. Because the question is you state and explain. Yes. Ionic radius increases down the group. Why? Why? Make a trial. Is the same. Is the same with atomic radius. There is increase in the number of energy levels as you go down. Yes, as you go down the group. Sasa nasikia network ni kama inakubali. Haya, part C.
How does the ionic radius and atomic radius of a given element in a family compare?
Yes. Yes, ionic radius and atomic radius of a given element in a family. Which family? The alkali metals. So let us compare the let us compare the ionic radius and atomic radius. Here, we talk about whether it is larger, which one is larger or which one is smaller than the other. That is the comparison. Yes?
Yes.
Between ionic radius and atomic radius. Which one is larger than the other or smaller than the other?
Atomic is larger.
Atomic radius is larger than ionic radius. Correct. Why? Naona uko sawa. Why? Make a trial.
Because
which one? It what? Which one? Be specific.
The atomic.
Yes. The atomic radius
is more given in the energy levels than the ionic.
It has more energy levels. Yeah, atomic radius has more energy levels as compared to ionic radius. Why? Because alkali metals, they ionize by losing an electron, which leads to loss of energy level.
Yes.
Yes, kwa hivyo kwa atomic radius wakati tuna form ion tunapoteza energy level moja kwa alkali metals. Tunapoteza electron moja. Tukipoteza electron moja tunapoteza na energy level. So you find that the ionic radius will have less energy levels. Kwa hivyo ni ndogo. Sawa sawa.
Yes.
That is correct. Okay, number 3.
An element whose atomic is 14 has 3 isotopes A, B, and C.
Good.
Use the information given in the table below to answer the question that follow.
Yes. Okay. Don't read, but you can see. I can also see. So read part A.
Determine the relative abundance of isotope B.
Haya, chukua kalamu ufanye na mimi nifanye, nilikuwa sijaifanya, uniambie jibu. You should get the same answer very fast because now that is a calculation. Relative atomic mass. Unipatie jibu. Haraka haraka, take a pen, whatever, do it. Sawa.
Yes.
And the atomic, there's an element of the atomic is the REM. It's supposed to be the REM.
Yes.
It's supposed to be the REM. So.
A nimepata 5.0.
Good. 5%, right?
Yeah.
Oh, correct.
B nimepata
Umepata
6 iko right.
umepata ngapi?
1.45.
1 point. Hebu ipitie tena because is supposed to be, we say that the relative atomic mass is supposed to be closer to the most abundant, to the mass of the most abundant isotope. So it's supposed to be closer to 28. Your answer is supposed to be closer to 28. Sawa? Yes. Oh, 14 and naile 14. Oh, no, sorry, 14 is not the RAM. Tunatafuta RAM. So, tafutia 14 is your RAM because now you want the RAM. Tafutia uniambie ni ngapi. Iangalie tena, yeah, but A is 5%, so tafutia B. Mimi nimepata 27.61. Unapata ngapi? Okay.
Yangu inakuja 14.25.
Okay. Let us do it together. So let us do it together. There we are. So here, what you're supposed to do, you take the mass number. So 28. Look at the board. Can you see the whiteboard?
Yes.
Tufanye pamoja sasa times 92, but wewe ndio utanipatia majibu, una multiply pale times 92 times 92%. Hiyo ni moja, close the bracket, plus the other one, mass 30, percentage abundance 3. Close the bracket. Hivyo ya mwisho, the last one is supposed to be 29. That is the mass. Then times, from the Roman 1, we have said the percentage abundance is 5. Close the bracket. You are supposed to have that. Then all over is simpler when you take over 100 kwa zote instead of moja moja. Sawa sawa?
Yes.
Yes. Okay, give me the answer for the first part. 28 times 92.
2,576.
2,576. Correct. Aya, the other one?
90.
90. Na bado naandika pale, angalia. Naandika 90. Aya, then lastly
145.
hapo ndio ulikosea. 195. Is it 145? Oh, 145. Well, yeah, 145. Correct. You are right. 145. You are right. 145. Then I add them. So all over 100. Add them. Add ziongeze. Add them.
2811.
Sasa hata ndio imekuja vizuri. This is 2,811. 11. No, taratibu tu, then all over 100.
28.11.
Very good. 28.11. Now, the RAM has no units, so that is the answer. It has no units. That is the answer. Then again, you can check. You can confirm whether you are right or wrong, because we say that the RAM, the relative atomic mass, is supposed to be closer to the mass of the most abundant isotope, and in this case, the most abundant isotope has mass number 28. You know, 28.
Yeah.
Yeah. So jibu yetu lazima, that must, lazima, it must be closer to 28 than any other isotope. Kumaanisha tumepata, kwa sababu 28.11 is closer to 28 more than any other. Sawa sawa?
Yes.
Yes. Very good. Very good. Let me close this. We go back, because the intention here is for you to understand. That is the intention. Okay. So we go back to the question. Hakuna haraka hadi uelewe. Key thing here. This is the key thing. So again, now the paper is there. You are at number what?
4.
Number 4. Okay, there we are. Read number 4.
A sample of water in a beaker is found to boil at 101.5 degrees Celsius at 1 atmospheric pressure.
Yes.
Assuming that the thermometer was not faulty, explain the observation.
Correct. Right. Kwa nini boil at 101 na tunajua inafaa kuwa 100? That's the question.
It was not the water was not pure.
Very correct. The water was not pure. Very correct. Always naona uko sawa. Very correct. The water was impure. That is because okay, the question is 3 marks. So what you are saying is correct. But for you now to get the 3 marks, you need to say the water is not pure. Sindio?
Yes.
Yes. Why do you say that? Because impurities increases the boiling point. Yes, and make sure I told you, make sure you write something, at least to revise. Impurities increases the boiling point. Yes, increases the boiling point. You get your 3 marks. State it is not pure since the boiling, I mean impurities increases the boiling point. Sawa?
Yes.
Very good. Hapo umenifurahisha kabisa. Hapo ni sawa. Haya, number 5. Read number 5.
A student set up the test tubes to investigate rusting of iron.
Yes.
Study it and answer the question that follows.
Correct. I have study. You can see them. There is tap water, some nails in A. Part B, tap water. I mean, we have nails, we have oil. Part C, we have boiled water, and we have the nails. Okay, read the question. Part A.
Identify the tubes where rusting occurred.
Yes. Try that also.
A.
Mm.
A and C.
A and C. Where rusting occurred. Good trial, but I think C is not part of it.
A only.
A only. Okay, let's explain. Oh, it's just to identify. But let's see. With the reason, yes. So identify the tubes where rusting occurred. A. That is just to identify. Higher. Some are part B. We are through with that. Part B.
Yeah. With the reason, state the test tube where rusting did not occur.
Yes. Okay, let me go back. Yes. Which test tubes? Yes, you state where you state and explain the test tube where rusting did not occur. Yes. Test tube what and what?
B and C.
Okay, let's start with the explanation at B. What is the reason why was there no rusting at B? Because of
due to the presence of the oil.
What is the problem with the oil? Yeah, it's correct. There is oil. So the oil does what?
It does not allow oxygen in
to enter into
the
correct.
jar.
In the jar, and oxygen is necessary for rusting, right? It's a condition necessary.
Yes.
Yeah, sawa and hivyo. So you don't just talk about oil, but talk about oil preventing the entry of oxygen in the tube. So that will prevent rusting. Okay. Part C again discussed. Why?
Because the water was boiled.
So
hence there is no oxygen.
Boil water. When you boil water, you escape the oxygen. Oxygen will escape. Sawa.
Yes.
And again, remember, it must be cooked. That one again, it must be cooked because usipofunga hapa juu, in part C, usipo cook hapa juu, air will enter again. Sindio? Yeah, so you must cook. So after boiling, you can see boiled water. So oxygen escaped, air escaped. Then the tube is cooked, imefungwa pale juu. So air cannot re-enter. Sawa?
Yeah.
So that one again, you must be very careful because inaweza kuja swali lingine, it is not cooked. So after some hours, the boiled water will cool down and the oil will re-enter. So it must be cooked. Lazima ifungwe pale juu. Sawa. Number 6.
A mixture was found to contain sodium chloride, sand, and iodine. Describe how each of the substances can be obtained from the mixture.
Okay, yes. Okay, 3 marks. Let's start. Make a trial.
You dilute the.
How do you dilute? You add water.
You add water. Yes.
Yes. Add water to the mixture.
Yes.
Mm-hmm.
Then you stir.
You stir, correct? What will happen?
The sodium chloride will dissolve in the water, leaving sand.
Correct.
Leaving sand at the end.
Iodine. Yes, sawa. Leaving, yeah. So sodium chloride will dissolve, while sand and iodine will not. Continue. Uko sawa kabisa. Continue.
Then you filter the solution. In which sand will be obtained.
What about iodine? No, sodium, you have filtered, so sodium chloride, so sand and iodine will remain as residue. Hello?
Iodine
Collins?
Iodine will dissolve.
Are you sure? Are you sure? Are you sure? Hello?
Hello?
Yes. Dissolve, after adding water, you stir, sodium chloride will dissolve. Sand and iodine will not. So you filter. So you will remain with sand and iodine as residue. Then you heat sand and iodine, the mixture of sand and iodine, where iodine sublimes.
Oh, yes.
Sawa.
Yes.
Sawa. Yes, where iodine will sublime. Kwa hivyo utapata sodium chloride, utapata sand and iodine. And remember, after sodium hydroxide dissolves in water, you need to evaporate water to remain with the sodium chloride. Sawa?
Yes.
Yeah, so that is okay. This question is common, and it must be procedural. Sorry, it must be systematic. Lazima ifuatane. Ukiruka step moja, huwezi makiwa tena. Sawa?
Yes.
Lakini nimeona umejaribu. You could have gotten 2 marks. Okay, number 7. Again, this question in paper 2 chemistry, very common. Who I call periodic table. Yes?
Yes.
Yeah, read.
The diagram below represents part of the periodic table. Use it to answer the question that follows.
Yes. Right?
Write electronic arrangement of the following elements.
So we start with A. Niambia haraka A. Electron arrangement. A.
2.
2.
1.
2, 1. Correct. D.
2.
4. Ngoja, there is something I want to note here. Mm-hmm. 1, 2. Two, 4. Continue. The other one, E.
2, 8, 3.
Very correct. Sawa sawa. Hapo ni sawa kabisa. Okay, part B. Very correct. Right, read the question.
Read the formula of the compound found between C and D.
Yes. C and D. Go back. C and D. C and D. They are there. C and D. Formula of the compound formed. Yes. C and D. Make a trial. Make a trial. Make a trial. Okay, let's start.
D.
What is the start with the C. Start with the C.
Oh, C. C. C minus 2.
C minus 2. What do you mean?
C.
We need the formula. C. Okay. What is the electron configuration of C? We start there.
2, 8, 2.
Correct. So what is the valency of C? What is the valency of C?
Minus 2. Negative 2.
Oh, I've got a new. Let's go back a bit because we need to. I need to explain to you something here. There is what we call oxidation number. There is charge. There is what do we call it? There is valency. Sawa, oxidation number, charge, and valency. All of them, they talk about the number lost or gained by an atom. Si ni kweli?
Yeah.
But charge huwa inawekwa pale juu, superscript pale juu, right hand side of an element of the symbol. Sawa?
Yes.
And we when writing charge, we start with the we start with the number, then sign. For example, calcium, we write Ca2 plus. Our is our.
Yeah.
But when we come to valency has no. Okay, sorry. We start with oxidation. When you talk about oxidation, we start with the sign, then we go to number. For example, what is oxidation number of calcium? The answer is +2. Hiyo sawa?
Yes.
Okay, just plus 2. Oxidation number of calcium plus 2. Okay. What is the charge? Sorry, what is the valency of calcium? The answer is 2 without sign. Are we together?
Pardon?
Okay. The whole part, huh?
Eh.
Okay, sawa. Nimesema nimeandika oxidation, and that's why I'm saying you take some notes. I've said oxidation, charge, and valency. Oxidation, charge, and valency. Sawa?
Yes.
Yes. Okay. We start with the charge. I want us to start with the charge. When you talk about charge, because all of them, they talk about the number lost or gained by an atom. Zote zinaongea juu ya ile namba ambayo ya electrons zimepotea ama zimekuwa gained. Zote. But now the way we write them differ. The way we write them differ. Charge huwa inaandikwa pale juu kwa element, right hand side superscript. Are we together? Pale juu, I believe you know how to write it.
Yeah.
That's why nikasema, take an example of calcium. How do we write calcium ions? It is Ca, pale juu right hand side 2 plus. Ni sawa?
Yes.
We go to oxidation number. What is the oxidation number of calcium? The answer is plus 2. So we start with plus, we start with the sign, then number. We start with the sign, then number. Sawa?
Yes.
What is the valency of calcium? What is the valency of calcium? The answer is 2. Bila sign yoyote. The valency has no sign. Valency has no sign. Are you together?
Yes.
Let us go back to our question. Okay. You have told me that the electron configuration of C is 282, which is much correct. Which is much correct. But now, what is the valency of C? What is the valency of C? What will be the valency of C?
2.
82. Hello.
2.
Correct. Sasa umenielewa. Namaanisha hivyo. Haya, kwa hivyo valency of C is 2. Valency of D? With electron configuration 2, 4? 4, correct. Haya, what they do, they interchange the valencies. What will be the formula of the compound formed? And you start with C.
C2.
2 hapo chini, alafu C2.
D4.
Ngoja. There's something there. We have said, unakumbuka ile concept ya ku-interchange valencies form 2? Yes, so tumesema C unafaa kuandika hapo. C hapo chini unaandika 2. Then D hapo chini yake unaandika 4. Let them interchange. So you will get C 4 D 2. But 4 and 2 ni multiples. Kwa hivyo itakuwa C2 D1. Hakuna haja ya kuandika 1. So ni C2D. Do you need much explanation? Tuende kwa whiteboard.
Nimeelewa.
Yeah, so unapata C2D. Sawa sawa? Aya. Then there is something here you are supposed to note. Wakati umeulizwa write the formula. Don't be specific. Usianze kusema sasa C, because for example in our case here, C naona ni 1 2 3 1 2 3. Naona kama ni what? Is it magnesium? Calcium, sorry. 1 2 2 3. Magnesium. C ni magnesium. Sawa?
Yes.
So unasema when you are asked to write the compound, usiseme ni compound gani, just use the symbols that are there. Don't go to an extent of saying writing the symbols, the chemical symbol of the specific element. Just use the letters. Are we together?
Yes.
Yeah, ukitumia hizo atuseme sasa ni magnesium, unakosa kila kitu. Okay, E and D. Do the same. Tell me the answer haraka haraka. E and D, compound. E and D, compound. E and D. Haraka haraka sasa unajua. E and D. And you start with E.
E1D.
E1?
D.
Not B. Is it B? D for dog. D for dog. D for dog. Look at the questions. E and D. D for dog. Sawa? Haya, nipatie. Inakuja E. Inakuja
E1D.
Kuna mahali hujanipata vizuri. Haya, wacha tuangalie tena. What is the valency of E?
3.
For dog. D.
4.
4. Haya, sasa siniandikie compound na uanze na E. Unapata E
4.
E4 D
3.
Yes, ni hivyo, sawa, correct. Umenielewa lakini? Very good. Haya, number 8. Uko sawa? Haya, number 8.
State 2 types of flames and in each explain how it can be produced.
Okay. Yes, state 2 types of flames and in each explain how it can be produced. Yes, state the flames. The types of flames. We have what and what?
Luminous and non-luminous.
Yes. Explain how they can be formed, the two of them.
Closing the air hole and
Which
opening
one? Which one?
Luminous.
Yes.
Is obtained by opening the air hole, while non-luminous is obtained by closing the air hole.
Very correct. Very correct. Okay, part B.
State 2 ways of preventing rusting.
Yes. You can state even 5 if you know them. Yes. Just to remind ourselves.
Painting.
We have painting 1.
Oiling.
Oiling.
Coating with other metals.
Yes.
Ingine ni gani?
We have alloying. Alloying, whereby you take iron, you mix with another metal in a certain ratio. You mix with another metal. Alloying. We call it alloying.
Oh,
Then we have sacrificial protection. Sacrificial protection. You take a metal higher than iron in the reactivity series. You take a metal higher than iron in the reactivity series, for example, magnesium, then you sacrifice it so that it can react with oxygen and water instead of iron. Unaelewa?
yes.
Una sacrifice magnesium. And by the way, that is the one that is commonly used in pipes, metal pipes for oil and whatever, because they are made up of iron. Those which are made up of iron, after some meters, wanaweka magnesium hapo chini to sacrifice magnesium for iron. That is sacrificial protection. Are we together?
Yes.
Aya, number 9. Naona tunasoma vizuri sasa. Yes, number 9.
The table below gives the number of electrons, protons, and neutrons in substances X, Y, and Z. Study
Yes.
it and answer the question that follows.
Yes. Okay. Roman 1.
Which letter represents an ion?
Okay, yes. Which letter represents an ions? An ion.
Why?
That is an ion. Why? 10 electrons, 8 protons. Yes, why? Yes, because in an atom, the number of electrons equals the number of protons. Indio?
Yes.
So it means if you have 8 protons and 10 electrons, we have there is a gain of 2 electrons. It's sawa. Yeah, you are correct. Part 2.
Which of the substances are isotopes? Give a reason for your answer.
Yes. Now I can see it is direct. Yes. Which ones are isotopes? You need to know what isotopes is.
X.
X. Collins. What are isotopes? What are isotopes? What are isotopes? Tuanze hapo. These are atoms of the same element having the same number of protons but different number of neutrons. Si ni kweli?
Yes.
Iko na same number of protons lakini neutrons ni tofauti. Haya, niangalilie ile iko na same number of protons. Those are the isotopes. Same number of protons, yes. So we have what and what? Yeah, so unaona sasa ni rahisi. Okay, yes. So Y and Z. Why? Because they have the same number of protons but different number of they have the same number of protons but different number of neutrons. Yes, so that is the explanation. That is the reason. Draw the atomic structure of element Z. Draw the atomic structure of element Z. I want us to draw icon 888. Okay. Icon number 9. Nataka tuchore pamoja just to remind ourselves. Atomic structure 888. 888. Yes. Here we are. Okay, so we have we can have the nucleus, then tukue na the first energy level, then the second energy level, Do you have the third one? Okay, so it is Z. Okay, how many protons? All of them tumeona ni 8. Sindio? Sawa sawa. Acha tuiandike hapa ikiwa kubwa. So we have 8 protons, 8 neutrons. Hivyo sawa sawa. Alafu we can use cross, so 1 2, kwa sababu tunaenda up to 8, we need another energy level. We need another energy level. There it is. So itakuwa na ngapi? The first one has 2, the second one will have
6.
6. Correct. Correct. And I believe you are drawing. You need to remind yourself. You need to draw it there. Hello. 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 Hello, Collins. Hello. 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 Okay. It is like that. It is like that. That's the structure of the atomic structure of Z. Atomic structure of Z with 8 electrons, 8 protons, and 8 neutrons. Thank you. Hello.